Question 8. A car stops at two sets of traffic lights. Figure 2 shows a graph of the speed of the car v meters per second as it travels between the two sets of traffic lights. The car takes t seconds to travel between the two sets of traffic lights. The speed of the car is modelled by the equation v is equal to 10 minus 0.4 t ln t plus 1, where t is between 0 and capital T, where t seconds is the time after the car leaves the first set of traffic lights. According to the model, part A, find the value of t. So when v is equal to 0, that's these 2 points here on the graph, and when we have an equation written as two products, v is equal to 0 when either 10 minus 0.4t is equal to 0, or when ln t plus 1 is equal to 0. Now, ln t plus 1 is equal to 0 when t is equal to 0, and that's the first value that we already have, and so the value we're interested in is when 10 minus 0.4t is equal to 0. And rearranging this, adding 0.4t to both sides and then dividing by 0.4, we get t is equal to 25. And so a capital T value is 25. Part B, show that the maximum speed of the car occurs when t is equal to 26 over 1 plus ln t plus 1 minus 1. Well, if the maximum speed of the car is here, that is when the gradient of this function is equal to 0. So we need to find dv by dt. So we have v, 10 minus 0.4t ln t plus 1. We're going to use the product rule to differentiate this. So if we let u equal 10 minus 0.4t, and I'm going to use z instead of v here because v is our velocity. So our second function, z, is ln t plus 1. Then I need du by dt, differentiating u with respect to t. 10 differentiates to 0, negative 0.4t minus 0.4, and then differentiating z, ln of t plus 1 differentiates to 1 over t plus 1. Now putting this together with my product rule, which would be u z u dash plus u z dash, gives me a dv by dt of minus 0.4 ln t plus 1 plus 10 minus 0.4 t over t plus 1. Now we want the gradient equal to 0, so we're going to let the gradient equal 0. Therefore 0 is equal to our equation of dv by dt, which we've found. Now we're going to start doing some rearranging of this, because this is our goal. We want this here. So let's start by adding 0.4 ln t plus 1 to both sides. This looks a little bit neater. Now if we multiply both sides by t plus 1, on the left here we've got 0.4 lots of t plus 1 ln t plus 1, which is 10 minus 0.4t. If we divide everything by 0.4, just tidies up the decimals. So t plus 1 ln t plus 1 is equal to 25 minus t. If we expand the brackets on the left hand side here, we've got t lots of ln t plus 1 plus ln t plus 1, which is still equal to 25 minus t. So adding t to both sides and subtracting ln t plus 1 gives us t lots of 1 plus ln t plus 1, which is 25 minus ln t plus 1. Now I can divide by this 1 plus ln t plus 1. And on the numerator here, this numerator of 25 minus ln t plus 1 could be written as 26 minus 1 plus ln t plus 1. And so we can see, and we're using our answer here to work back a little bit, that t can be written as 26 over 1 plus ln t plus 1 minus 1.